Hey, welcome back. We've got our 06 Bad Mama Jamma twin turbo Corvette.
Now, serious Bad Mama Jamma, we're talking 600 plus horsepower at the rear tires. Now, when you think about that, that requires a lot of work up in here, a lot of that, prevention of detonation that we always talk about, the catastrophic engine killer. So Bird is gonna get his nerd on and show you guys a little bit about ignition and timing.
That's right. Now step into my office. We're gonna look inside the cylinder. So if we look at our piston, we've got our cylinder. If we were to put a pressure sensor in there and monitor what's happening during that whole combustion event, we can look here, we've got crank angle, and we're looking at the pressure. So somewhere down here at bottom dead center, you're gonna squeeze that air and fuel up, right? And then if I don't ignite, if I just keep rotating the crank, I'm gonna undo that and end up right kind of where I started. So that's without burning the fuel. Now, fuel doesn't just instantaneously ignite and just create a violent event. It actually takes a little bit of time. So we've got to get some spark advance in that engine, get that little kernel started, grow that flame, let it get, full frontal, and, start that big process. But in relative terms, it's a gradual, even though it happens really fast. So somewhere out here, I'm going to ignite that sucker, and I'm going to let it start to, burn, but it's going to build pressure. So I'm actually pushing and I'm working against that pressure I'm building, but if I let it keep burning, I get this big rise, and as my piston drops, my pressures are kind of dropping with it, but I'm extracting all this work, and all of this is what gets to the tire. I have got a little bit of work to go into it, but I get a lot more out of it. Now, unfortunately, we've got knock limits. Now, somewhere up here, depending on, the pressure and temperature, we've got an area, this no-go zone, called knock. And as a lot of you are familiar, you can kind of hear a rattly, clanking sound. And what that is sort of a violent, immediate, instantaneous burn of everything. It's not controlled anymore. So if I started here and I start to get knocked, I might get some big spikes up there. And those spikes are what crack pistons, they buckle rods, they destroy engines. So this is a no-fly zone. We want to stay away. So if I've got this limit and I've already got a performance engine, well, how do I add boost and make all that power? Well, we can kind of cheat the system a little bit. I can, instead of spark advancing this far before TDC, I can start retarding my spark. What does that do? Well, I start to ride up here, and I can even start to come down a little bit on this before I really start to get my burn. But because the piston's dropping away, I've got more volume. I don't end up with that same really high pressure anymore. So I can sort of ride this knock limit line, and I just delay a lot of the work till my piston's a little bit farther down the bore. Now, it's not quite as efficient, but when you've got a wide open throttle and you're making 600-700 horsepower, you're not really concerned about ultimate efficiency, you're concerned about making power. But as soon as I back off of that, I'm in sort of my normal operation mode, and I get my perfect fuel economy and my perfect, efficiency. So with the knock limit on sort of regular fuel, we've got to go into this whole engine spark table and that 80%, 100% wide open throttle, and really start pulling this spark back, so we don't detonate the engine, but we want to try to ride this line to make every horsepower we can.
Okay, so Kev was giving you a whole dissertation about the knock ceiling. So if we could raise that knock ceiling, chances are you get a lot more power out of the motor. So how do you do that? Methanol injection is one great way to do that, and an economical way as well. So think about two properties of methanol. All right, it's a high octane fuel, super resistant to detonation, and it's cool. Everybody that's ever poured rubbing alcohol on your arm knows that cool feeling. So if we can inject some of that into our intake right here, you imagine the intake inlet temperatures super cool. It actually cools it by 60, 80, even up to 100 degrees. Kind of neat. That allows for more ignition timing and more boost as well. And one of these kits are really easy. All you need is the injector, the tank here, which he uses windshield wiper fluid, and you need an air sensor gauge and a pump, and you got yourself a methanol injection kit. Not so bad. But adding more ignition timing, more boost, that means we've got to change a lot of the parameters in and around the car.
Hey, welcome back. We've got our twin turbo Corvette here making big time power, over 600 horsepower to the wheels, and we're walking you through what's going on inside the engine, but we're working our way out to the controls and the tuning. But before we do that, one of the things we want to make sure you do, we've upsized our injector. So we went from a 28-pound to a 60-pound injector. So we've got to make sure that that PCM knows what's in there. Well, it's not as easy as a constant flow rate. Take your garden hose, squeeze the little nozzle on the end. It doesn't instantly shoot out a constant flow rate. It has to sort of build up that charge. It's got to ramp up, then a steady state, and then it's got sort of a decay. Well, we got to make sure all that information is in there. Now here's sort of a chart we've gotten from Calibrated Success, a great resource for picking up a lot of injector information and tuning information. So here's the characteristic curve. So this is pulse width. So this is what I've asked the injector to do as far as time, and this is my flow rate, and this is my stock injector. And you can see from 0 to about 1 millisecond, maybe a little longer, nothing's flowing. Well, it takes a little time to charge the coil in that injector, get that needle to move, get the fuel to flow. Well, you can see it's also got sort of a knee in the curve. So this shape is really important for the computer to know, because once it does, it's going to be able to make sure that it dials in for very short pulse widths, because you're not always flowing somewhere out in here for a long period of time. It's constantly shutting on and off. So we're going to step up here to the blue curve. That's the 60-pound Siemens Deca injector. And with some software we've got from HP tuners, what's really cool is we can take all of that information and we can put it right on that PCM, and we're going to have kind of a factory high-level calibration. Perfect fuel economy, best performance, all the drivability that you expect from a modern car. Well, they've got a data logging suite, and they've got a huge power hardware and tuning configuration suite. Now here's just a sneak peek at how powerful the OE PCM is. Stuff that an aftermarket controller is never going to be able to do, because they don't have the millions of dollars and all the engineers. This is an even more enhanced characteristic, or actually this is a correction factor for the fuel injectors. So this is a three-dimensional map that you've charged that injector, you want it to open, but what if my battery voltage changes? Well, I've got a correction factor. What if my manifold vacuum changes? So I'm effectively changing the difference in pressure between my fuel rail and the manifold. It's going to flow different. So I've got all these correction factors and tables that I've got access to with HP tuners that I can make work on this particular configuration and make it run awesome. So I've got that injector information downloaded. So the next thing we're going to do right before we turn that key, and I'll show you, we've got a wideband O2. Now this is going to let us see the whole range of air-fuel ratios, and this is going to be our master gauge. So this is going to tell us everything that we requested of the PCM, how well the computer actually did to get us what we wanted. So this is actually going to pipe into our HP tuner data logging, and we can compare the results between the master gauge and what we're reading out of the engine, and we can make correction factors. And we can dial that sucker in till it's running like a top. So let's get all this in the car. Let's go get driving. All right, welcome back to Two Guys Garage.
Oh, yeah.
We got the laptop out, and you can see we've got a whole series of gauges. This is our HP tuner software. And if we kind of hide those gauges a little bit, we can see our streaming data.
Nice.
Right here. Now these are the same kind of inputs streaming across the screen as we go. What's cool is we can data log this stuff, go back to the shop, pull over the side of the road, and kind of compare what the engine's doing versus what we want it to do.
Okay.
All right. Now the first step before we go change in air fuel and spark is to dial that MAF sensor in.
Whew. Yeah.
Right? So remember we told you we've got that wideband O2 sensor. It's tapped in to exhaust. It's also tapped in here in parallel, so we're reading our master gauge and what the computer thinks it's doing. Now with a few more watt pulls saved on our data log, we can compare the two air-fuel ratios, the real one versus what the computer's thinking. Then we can dial that MAF sensor in till it's spot on. Now the computer, it's easy. The computer knows how much air is in, and now we can tell it what to do. So we got some good data here. We're going to find a good spot to pull over. We're going to check things out, make some corrections. As good a place as any to pull over is the gas station.
Amen, right?
All right, so here's our data that we've collected. It's stopped, but I can move forward and backwards. And this looks like a bunch of EKG readings. It looks kind of confusing, but these lines correspond to these values over here. So here's, for example, my commanded air fuel. This is what the computer, we asked the computer to do,
Right.
but this is what it's actually doing relative to that master gauge or the wideband O2.
It actually
and you can
tells
see,
you the percent you're off.
Right.
Kind of cool.
Yep, so this white line up here is wide open throttle. We got out of it a little bit, got back into it. But at wide open throttle, you can see these percentages that were off.
Right here.
Well, what's cool is we can go right back in. This is our vol F curve. This is that MAF sensor curve that we talked about, and it's off, and here's the values. We can take those percentages that we saw on our data log, we can change them, these numbers, by those same percentages, and dial that MAF sensor curve right in. So when we go back to our data log, right, that air-fuel ratio commanded is going to be the same air-fuel ratio that we would read with a master gauge or any other gauge that's right on the money, which is cool. All right, now the other thing you'll notice, we got our wide open throttle line here, but if we look, you know, as we're hitting right in this range, we've got spark retard. So that's knock, pulling spark out.
So I tipped in here, it's pulling 1.2 degrees out, but as you get closer, you'll see that go up 4.6, because you see a knock right here.
So we can dial that spark table in. This thing's gonna get closer and closer the more we go out and drive and collect data. It's a lot of fun.
No doubt, man.
So it's really cool the power you get with tools like HP tuners. You can see what's going on in that engine, so you're not scared to hurt something. All the data's right there for you. Then to go back in and dial it in just right.
Well, I think it's time for us to put some more laps on it, man.
That's right.
Need more data. Data logging.
That's right. Good thing we got a full tank of gas.
Yeah, and a new set of tires.
Yeah.